Okay, so here is problem 40. If you don't have it written down, you can write it. Some of you guys were half right in your solutions. There's some subtleties going on here, and it has to do with where the triangle is. So that's kind of what I'm going to address here.
Is that 3 of 13 or 5 of 13?
5 over 13. Okay. Now there's two different approaches to this. I kind of want to talk through both, and at the end, the cool thing is you get the same answer, but some of you might prefer one method over another, depending on if you're better at graphing and seeing things visually, or if you like algebra more. So we're going to look at the graphical approach first, and then we'll move on to the algebraic approach. Bless you. Alright, so here's where we're going to start. We're going to start with this. Before we do anything, if we're graphing this, what does this look like? That pi over 2 is less than theta, which is less than pi. It looks like your domain. This is exactly what it is, your domain. So if you're thinking about your quadrants in the unit circle, what I want you to do with your partner, think about the unit circle. What quadrant is this triangle going to be in based on the information? Talk to your partner, answer that question. All right, show me on your hand what quadrant we're in. Okay, we're in quadrant 2. Jalal, can you tell me why we're in quadrant 2? Okay, where is pi over 2 on the unit circle? How many degrees? It's right here, right? It might help for you to write this in, and pi is right down here, right? So what this means is this triangle is in between pi over 2, which is up here, and pi. What quadrant is this? 2. So now we draw our triangle in quadrant 2.
What if we decide to make the quadrants kind of like backwards-ish in a way?
That's a really good question, and I don't have the answer to it. I'm sure it's some. I mean, it is kind of counterintuitive. You would think it'd go clockwise, right? I'm not sure. I'll try to look that up. I'll ask Frank. Maybe he'll know. All right, so we're in quadrant 2. Now, when you are dealing with drawing a triangle, we are not dealing with the unit circle, even though we're dealing with the quadrants of the unit circle, because our radius isn't 1. It's actually going to be 13. Theta is always going to be right here because we are rotating around the unit circle. So your angle is always here. So what I want you to do now is you have a right triangle, right? We're going to use SOHCAHTOA. Label each side opposite, adjacent, hypotenuse. So take 30 seconds in your group. Which side's opposite? Which one's hypotenuse and adjacent? Alright, so we should all know what our hypotenuse is. There's our hypotenuse, right? We're going across. What side's this going to be? Opposite, and then my adjacent. So if we're dealing with the right triangle, and you're labeling all these sides, what we are thinking is we are thinking SOHCAHTOA. That's going to allow me to solve here. So I have my whole triangle set up. It's in quadrant 2. And I have opposite, hypotenuse, and adjacent. What do you think I'm going to do now with this sign? What information have I not used yet? The numbers, right? I know that sine of theta is 5 over 13. Sine uses opposite and hypotenuse. Go ahead, label your sides now. Match the opposite and hypotenuse up with 5 and 13. Opposite and hypotenuse. So we know that our hypotenuse is 13 and our opposite side is 5. Now this should make a lot of sense based on where it is. Thinking about your x and y axis, we're going up 5, right? Positive 5 value. And 13, this is always going to be positive because it's absolute value. I have two sides. How do I find the third side in a right triangle? Pythagorean theorem. Go ahead and find your adjacent side. Alright, I'm working this out with you guys. comes out real nice, right?
Yep.
What's your missing side?
12.
All right, 12. So let's go up to our adjacent side. Let's label it 12. Now here's where the subtleties come in. Wherever you draw this triangle, that length is 12. But since it's in quadrant 2, it's our x-coordinate. We're moving backwards. So it needs to be negative 12. And I know that's very small, but if you want to get a 4 on trig, this is the difference between a 3 and a 4. A 3, yeah, you get the 12. The 4 is, you know that the quadrant means we're going backwards, negative 12. Okay, you have all 3 sides now, right? Write a ratio for cosine now and tangent. You've done all the hard work. All right, so cosine of theta is equal to adjacent over hypotenuse. So be careful with your sign, negative 12 over 13. And tan of theta is going to be positive 5 over negative 12, which is a positive or negative, so it's still a negative.
But isn't tan negative response where it make it positive?
No, because if it was negative and negative, then it'd be a positive. And that would only happen in quadrant 3. Remember, all students take tangents positive in quadrant 3. The only thing that's positive in quadrant 2 is sine, which makes sense. Look, positive, negative, negative. Okay. Question. We'll do this together. So the algebraic approach algebraically uses one of your identities, and we haven't talked much about identities. We'll talk a lot more about them after break, but these come very important later in chapter 4. So the first identity we learned was this: sine squared of theta plus cosine squared of theta is equal to, anybody remember? Unit circle, it's equals to 1. Okay. It's the Pythagorean theorem with the unit circle, because sine is y and cosine's x. Now the next part of this is the only information I have from the beginning of the problem that I can use here is this. So what do you think I can do with that sine of theta? 5 over 13.
Plug it in.
Plug it in. So you're going to plug it in. 5 over 13. We're going to square it. Plus cosine squared theta equals 1. Now a lot of you I know want to reach for your calculators and do this, but you're going to get a decimal. So I just want you to square 5 and then square 13. Leave it as a fraction. Yep.
Why is it 1?
The reason it's 1 is because when we go back to the unit circle, we derived this from it. The unit circle had a radius of 1. So the equation for a circle is x squared plus y squared equals r squared. And x and y are sine and cosine. All right, go ahead. Square 5, square 13.
Wait, can
So you get 25 over 169 plus cosine squared theta equals 1. Now we're solving for cosine of theta. So algebraically, what does your gut tell you to do? What do we need to move?
I'll subtract.
Subtract. We've got to subtract 25 over 169, which I know sounds like a pain. And we can't do it with the 1 unless we multiply this and get it by 169 over 169. So maybe this will help you see it. So now we get 169 over 169, and we're subtracting 25 over 169 from it. Okay? Jeff?
Where does negative
For the negative 25, what we're doing is we're doing algebra, we're trying to get rid of it. We're just subtracting it. So it's a fraction, it looks more complex. So what's 169 minus 25? Yeah, you should recognize these numbers. 144 over 169, and that's equal to cosine squared theta. I need to get rid of the squared, because we're solving for cosine. Square root. You got it. Go ahead and square root both.
I see. Where did the negative come?
Over here, we'll talk about that. So square root of 144 over 69 is 12 over 13, right? Same kind of things we were doing over here. Same numbers are popping up. However, this isn't the right answer. We know the right answer is negative. You do not have to draw the triangle. This is how I want you to think about it. All students take calculus, right? You guys remember that mnemonic?
Yeah.
We're in which quadrant here? Quadrant 2. What's the only thing that's positive in quadrant 2?
Sine.
So cosine must be negative. That's it. So you just drop the negative in. Yeah.
Isn't there like
Tangent's equal to what?
sine?
Sine over. Have you already solved for both of those? All right, go ahead and write the fraction. Five over 13 divided by negative 12 over 13. And if you were to multiply by the reciprocal, the 13s, bye-bye, they cancel. So this is an easier way to look at it. 5 over, isn't that what we got for tangent? 5 over negative 12. So negative 5 over 12, same exact thing.
Where the